All right, Algebra 2, welcome to your Chapter 6 test review video here. Your test is going to be starting next Monday, the 22nd. Or I'm sorry, it's going to start next Tuesday, the 23rd, and then finish on the 24th next week. All right, so given f of x, g of x, and h of x, there are so many questions in here. I'm just mostly going to show the work. You're going to do f of x plus g of x, add those two functions together. Again, pause it whenever you need to. Number 2, you're going to do g of x minus h of x. Make sure h of x is in parentheses. You are subtracting 2x, then subtracting 3. Number 3 here, we have f of x minus h of x. Again, h of x needs to be in parentheses. You're subtracting all of it. Number 4, we got g of x times h of x. First outer, inner, last there. F of x plus g of x, add the two functions together. And the easiest one here is g of x divided by h of x. Another easy one, h of x divided by f of x. H of x divided by f of x. Number 8, you have 3 times g of x, so you distribute, plus 4 times h of x, so you distribute, combine like terms. Number 9, you have 2 times f of x minus 5 times g of x, distribute, multiply by negative 5 there. It's the first page. Again, all of these sections I would imagine seeing again. Numbers 10 through 15, identify the domain and range. Again, you're allowed to take the square root of 0. Anytime you have a positive number inside the square root, or positive x inside the square root, the domain is always x greater than or equal to some number. So the domain is x greater than or equal to 3 here. I can plug 4, 5, 6, anything 3 or more, and I'll have the square root of something that's allowable. All right. Anytime you have a positive square root function, which you do here, there's no negative on the outside, then the range is y greater than or equal to some number. All right. Number 11, again, you have a positive number, a positive x inside the square root. Domain is x greater than or equal to negative 5. That is a positive square root function, y greater than or equal to 1. Now on 12, you have a negative x on the inside of the square root, so the domain has to be x less than or equal to 8. That is still a positive square root function, so the range is y greater than or equal to 3. And 13, the last type question you can see. Here, the last type of situation is if you have the opposite of a square root function, then the range has to be y less than or equal to some number. That's still a positive x on the inside, so the domain is x greater than or equal to 1. Negative x on the inside, x less than or equal to 5. Positive root function, x greater than or equal to negative 5. All right. I don't know if I said 5, but that should be 7, as it says there. Positive x on the inside, x greater than or equal to 2. Positive square root function, y greater than or equal to negative 4. All right, so compositions, I figure out what g of 2 is first. I plug 2 in for x right there. 7 times 2 plus 3 is 17. I plug 17 in for x in the outer function, so I plug 17 in for x right there. Same type of deal in 17 and 18, mostly just check your work here. We'll talk about these again in class. That's the answer to 17. That's the answer to 18. 19, f of 1 is negative 10. I take negative 10, plug it in for x right there. Negative 67 is my final answer. F of 4 is 5. Then I plug 5 back in to x and f of x. I get 14. G of negative 4 is negative 25. I plug negative 25 in for x in the same equation. G of 0 is 3. F of 3 is negative 2. All right, so g of f of x. So f of x is x squared minus 11. So I plug all that in for x right here. It's going to be 7 times what I plug in for x, x squared minus 11, plus 3. I'm left with that expression, 7x squared minus 74. F of 3 is a negative 2. G of negative 2 is negative 11. probably a more interesting page here is find the inverse of each function. Again, f of x is the same thing as y, so I can write y equals 2x minus 7, and then I switch x and y. So this becomes x, this becomes y, and I solve for y. I add 7 to both sides, then I divide by 2. So y, or f inverse of x, is x plus 7 over 2. I got 3x plus 11, y equals 3x plus 11. Again, I switch x and y, x equals 3y plus 11. I subtract 11 both sides, divide both sides by 3. Y equals 1/3 x minus 5, so x equals 1/3 y plus 5. I'm going to add 5 to both sides. Instead of dividing both sides by 3, I'm going to multiply both sides by 3. Y equals x plus 7 over 2, so x equals y plus 7 over 2. Multiply both sides by 2, subtract 7. Y equals square root of x minus 3, so switch x and y. X equals the square root of y minus 3. If I want to free up this y, I need to square both sides. X squared equals y minus 3, then I'm going to add 3 to both sides. Y equals the square root of 2x minus 1. So x equals the square root of 2y minus 1. I'm going to square both sides. I'm going to add 1 to both sides. I'm going to divide both sides by 2. There we go. Take a look at 31 here. Y equals the square root of x plus 4 minus 1. So I have x equals the square root of y plus 4 minus 1. I'm going to add 1 to both sides. Then I'm going to square both sides, and I'm not going to call it x squared plus 1 because it's not. I'm going to call it x plus 1, all of it squared. Then I'm going to subtract 4 from both sides. 32, you got to be careful here at the end. So y equals 3x squared minus 7. So x equals 3y squared minus 7. Add 7 to both sides. Divide both sides by 3. Then I'm going to take the square root, and when I take the square root of both sides, it's like saying y squared equals 9. When I take the square root, it's plus or minus root 9, which is plus or minus 3. Got to have that plus or minus there. So a parabola, or x squared here function, it doesn't have a single inverse. It has these two, plus or minus. All right. And we are continuing here. Take the square root of 64, that's 8. Again, this 2 goes into 10 5 times. If I have 10 x's, I can make 5 partnerships. I can make 5 pairs of 2. 2 goes into 24 12 times. The third root of 8 is 2. If I'm looking for groups of 3 and I have 12, I'm going to make 4 groups because 3 goes into 12 4 times exactly. 3 goes into 21 7 times exactly. Square root of 100 is 2. 2 goes into 2 1 time. If I have 2 people, I can make a 1 group of 2. 2 goes into 6 3 times. 4 goes into 16 4 times. 4 goes into 28 7 times. Square root of 121 is 11. 2 goes into 2 once. 2 goes into 10 5 times. 5 goes into 25 5 times. 5 goes into 48 times. Now I don't have that jailbreak. On 28, I break up 28. It's 4 and 7. 4 is 2 and 2. So a 2 goes on the outside. A 7 stays on the inside. This 2 goes into 4 twice. Exactly. 2 goes into 7 3 times with 1 left over. So 7 and y is left inside the square root. Number 40 here, the square root of 40 is a decimal. So 4 and 10. This is 2 and 2. That's a partnership. It breaks out. 2 times 5. That's not a partnership. 10 stays on the inside. 2 goes into 3 1 time with 1 left over. 2 goes into 6 3 times exactly. All right, on 45, square root of 45, break it down. 9 and 5, 3 and 3. 3 breaks out. 5 stays on the inside. 2 goes into 5 twice with 1 left over. 2 goes into 7 3 times with 1 left over. 42, 4 goes into 22 5 times, 2 left over. 4 goes into 17 4 times with 1 left over. It's very important that this leftover here, this root is the 4th root, not the square root, but the 4th root. And the last 2 here, the cubed root of 27 is exactly 3. 3 goes into 10 for the x's 3 times, 1 left over. 3 goes into 7 twice with 1 left over. The leftovers are in a cube root, not a square root. 5 goes into 7 once with 2 left over. 5 goes into 11 twice with 1 left over, and the leftovers are in the 5th root. All right. 45 here. I can multiply on the outside. 4 and 5 give me 20. Multiplying inside, x to the 7th times x to the 5th is x to the 12th. Y to the 3rd times y to the 9th is y to the 12th. This 2 goes into 12 6 times. 2 goes into 12 6 times. No more root left over. 3 times 12 is 36. X to the, add the exponents 8th. Y to the 10th. Square root of 36 is 6. 2 goes into 8 4 times. 2 goes into 10 5 times. 8 times 5 gives you 40. Add the exponents for x. X to the 4th. Add the exponents for y. Y to the 8th. Break down 40. Pair of 2's. 2 times 2 is 10. Stays on the inside. 2 root 10. This 2 goes into 4 twice exactly. 2 goes into 8 4 times exactly. All right. Square root of 18. 9 and 2. 3 and 3. So 3 root 2 plus. Square root of 50, 25 and 2, or 10 and 5. Doesn't matter. You got a pair of 5s that break out. 2 stays on the inside. Minus 2 root 2. 3 plus 5 minus 2 is 6 of those root 2's. Square root of 20. 20 is 4 and 5. 4 is 2 and 2. It busts out. That radical jail immediately multiplies with 2 to give you 4 root 5 plus 80, 10 and 8. 20 and 4, 16 and 5. Now here's a pair. It's 4 and 4 could break out, or I can break it into 4 is 2 and 2. 4 is 2 and 2. You got 2 times 2, which is 4 that busts out. It multiplies with 3 to give you 12 root 5. That gives you 16 root 5 total. To get rid of a radical in the denominator, I need to multiply top and bottom by the conjugate. That is the same of the denominator. That's the same 2 terms. So 5, 5, root 2, opposite sign. So plus, minus. So down below, it's going to be 25 minus root 2 times root 2 is 2. Up top, it's going to be 15 minus 3 root 2. Here's my answer. All right, so we got first, 3 root 10. Outer, 12 root 2, inner, 5 root 5, last, 20. Multiplying with conjugates, I just have to do the first. 4 times 4 is 16, and the last part of FOIL, root 10 times root 10 is 10. 16 minus 10 is 6. On at 53, I want to get rid of the root 7 in the denominator. I'm going to multiply top and bottom by root 7 plus 1. Down below, it's going to give me 7 minus 1, which is 6. 5 root 7 plus 5 over 6. So 50 and 53 represent, some of the harder ones you might see. Overall, that is not the easiest page. All right, write it in radical form. So first off, this is x to the 1/2. That's what 5 over 10 is. So that means I'm taking the square root of x. Here I'm taking the 7th root of x squared. This is x to the 1/3, so I'm taking the 3rd root of x to the 1st. Here I'm taking the 5th root of x to the 11th. Exponential form, this is x to the 7 over 12, x to the 7 over 2, x to the 3/5, x to the 3/4. That should be an easy 8 questions right there. Should you see some of those again? I'm going to add the exponents without multiplying with the same base. 3 halves plus 5 halves plus 7 halves is 15 over 2. Add the exponents again. They all have a denominator of 3. So 2 plus 4 plus 5 is 11 thirds. Add the exponents again. I can make x to the 3 over 2 into x to the 6 over 4. Then I can add 17 over 4 and 6 over 4. I'm going to subtract the exponents here. 11 over 5 minus 3 over 5 is 8/5. Subtract the exponents again. 7 minus a negative 3 is 10. X to the 10/4 is x to the 5 over 2. Again, simplify fully. On 67, x to the 5/6 divided by x to the 2/6. Again, I'm making 1/3 into 2 over 6. Subtract the exponents. That's 3 over 6, which is 1/2. Square root of 81 is 9. Then I take the square root of 9, which is 3. Square root of 256 is 16. Then I take the fourth root of 16, 2. The square root of 15 is 625 is 125. Then I take the third root of it. That's 5. All right, I think the last 2 pages. If I want to solve a square root function, I need to make sure the square root's all by itself, which it is. I square both sides. X minus 3 falls on out. Add 3 to both sides. Square both sides. 3x plus 1 equals 25. And I go from there. On 73, I need to add 3 to both sides first. Then I get the square root of x plus 7 equals 7. Now I'm going to square both sides. 74. Subtract 2 from both sides. Then I'm going to square both sides. 75, I'm going to add 2 to both sides. So the 1/2 power, that is the square root. So I'm going to raise both sides to the second power, i.e. square both sides. Then that's how I get my answer. On 76, I'm going to raise both sides to the third power. That's 27, 3 to the third, not 9. Again, you guys can go from there with the work. Pause it whenever you need to. I'm going to add 1 to both sides. 2x plus 3 to the 1/3 power is 2. I'm going to raise both sides to the third power. 78, just simply square both sides. Those fall out, x equals 7. I'm going to do the same thing on 79. I'm going to be careful when I square the right side, it's just x plus 11. But when I square the left, yes, the x plus 1 comes down, but I got to square 2. 2 squared is 4. Then I got to distribute, and then I can get my answer. And 3 or 4 more here, the final page. I'm going to add 2 to both sides. Then I'm going to divide both sides by 3. Now I'm going to square both sides. Again, decimals are okay, fractions are okay. 81, I'm going to subtract 1 from both sides. Divide both sides by 2. Then I'm going to square both sides. And 82. Subtract 2 from both sides. Divide both sides by 5. Square root of x minus 3 equals 4. I can square both sides. And finally, 83. Let's end it on a good prime. I'm going to subtract 11 from both sides. I'm going to divide both sides by 2. Then I'm going to square both sides. 101. All right, this is your test review video. They did very, very well before the pandemic started last year. On this test, you guys will as well. This is the Math Video signing out.